Perfect. As the particle passes through a point, so this is sine x, pretty much. This is not an exact graph, but I picture the point. They say 1 comma, no, 1/3 comma 1. Its x coordinate increases at a rate of the square root of 10 centimeters per second. So what does this mean? The square root of 10 centimeters per second. Its x coordinate increases at a rate of the square root of 10 centimeters per second. What does this mean? What is this?
Well,
dx over?
dt.
Very good. The rate of change of x with respect to time at a particular instant. Fine. How fast is the distance from the particle to the origin changing at that time? I'm going to call this W. So before we read the problem one more time, what is the question here? What are we asked to determine? We're asked to find, okay, let's read it one more time. It's not clear, obviously. It's not clear. Good. So a particle moves along a curve. As the particle passes through this point, its x coordinate increases at a rate of how fast is the distance from the particle to the origin changing at that particular instant. So we are asked to find dw over dt when x is, very good, 1/3. This is the question. So we're asked to find the rate of change of the distance with respect to time when x is 1/3. You do not have to cross out anything, but I have to make a point. This is not what I'm trying to do at the beginning. What I'm trying to do at the beginning is picture the graph. Picture any point x, comma y, of course, y equals 2 sine pi x over 2. And I picture the distance, which is w. I will not be fooled by what they are trying. They're trying to trick us into using this before we find an expression for w and the derivative for w. So this is the general situation. The particle moves along this curve, and at a particular instant, this is the distance between the origin and the particle. I see a right triangle in which this is the x and this is 2 sine pi x over 2, and this is the w. I need to find the relationship because all I have is x, y, and w. I need to find the relationship among these three. And the relationship is clear. What do you think we are going to use? What do you think we're going to use? The Pythagorean theorem, in which we write w squared equals 2 sine pi x squared plus x squared. This is the relationship between x at any point on the curve, y at any point on the curve, of course they are related, and w connecting the origin to the particle at any point on the curve. What do you think the next step would be? Differentiate. I have to put 1/3 in this, and I don't have it yet. I only have a relationship. So we differentiate the left-hand side, and we differentiate the right-hand side. Remember, W and X are functions of time. Excellent. Good. So the left-hand side, 2W times?
dw over dt.
Excellent. The right-hand side, we can simplify it a little bit and just write 4 sine squared pi x over 2 plus x squared, if that helps you. So I have to bring the power in front and multiply by 4. So that's 8 sine pi x over 2 times sine pi prime, which is cosine pi x over 2, times the inner function prime, which is pi over 2, times
dx over dt.
excellent, because x is not x is also a function of time, it's not a variable. Excellent. Plus 2x times the inner function prime, dx over dt. One more time, let's start from the beginning. One more time, please. Make sure this is clear. So we obtained a relationship. The particle moves anywhere on the curve. And I'll say, stop, Mr. Particle. And at this instant, I see x, I see y, and I see w. For this right triangle, I write the w squared equals the height squared, the leg squared, plus the other leg squared. So when I square this, I get 4 and sine squared, and then x squared is x squared. And I say, fine, I have a relationship between w and x, both functions of time. I differentiate the left-hand side as 2w times dw over dt equals 8 sine to 2 minus 1 times sine prime times the inner function prime, which is pi over 2 times dx over dt, and then plus 2 times x times dx over dt. Now, all I want is to find this, which is dw over dt. Notice that this is one term and this is one term, and I can simplify by 2. I simplify this by 2, this by 2, and this by 2. So I only divide by w. So this divided by 2 will be 4 sine pi x over 2 cosine pi x over 2 times, I could have put pi over 2 in front also, and I will, pi over 2 in front, dx over dt plus x dx over dt. So then this becomes 2 pi. I'm going to write it one more time for everyone to see. dw over dt equals 2 pi sine pi x over 2 cosine pi x over 2 dx over dt plus x dx over dt over w. And now I will say when x is 1/3. And you can say, wait a minute, because you didn't determine w. Oh, there's no problem. From here, I can take the square root and find w. So this piece will be the square root of 4, of course, 4 sine squared pi x over 2 plus x squared. Let's see if we have everything we need. Yes, we do. X is 1/3. How much is dx over dt? It was given to us. Yes, the square root of 10. And that's all we need to do. Plug them all in and get the final answer. Please do that. We have one more minute, and I want to select a few problems for you to work on. Seven and 9 on page 234. 13 on 248. And 1 on 233. Okay, do we have the number? Okay, in parentheses, for the top, 2 times pi times sine pi 1/3, so it's in parentheses pi divided by 6 because it's 1/3. Close the parenthesis, cosine in parentheses again pi divided by 6, the same thing. And this is multiplied by the square root of 10. And then plus the square root of 10 and outside divided by 3. Close the parenthesis, and now a little struggle with the denominator, the square root of 4 sine pi over 6 squared and then plus a 1/9. Here's what I got. 9.1620 or 21. And this is in centimeters per second. Double check my numbers. Don't trust me today with numbers.